Hello everybody, thank you for coming today. My name is Salaheddin Sharif. I'm a PhD student at Sport and Exercise Science. Today I'm presenting research about the effect of resistance exercise and chemotherapy, doxorubicin, on antioxidant enzyme in fast muscle, skeletal muscle type 2. And this study have been cooperated with Creighton University, with Dr. Eric, who was being graduate like a few years back from our program, under supervision my advisor, Dr. Haidak. So I'm going to start talk about the cancer treatment of chemotherapy. One of those is called doxorubicin, is very highly effective, treated in many type or several types of cancer, but its using being limited because have a lot of side effect. Well, one of the most common side effect is cardiotoxicity, which causing congestive heart failure. Also, another side effect is myotoxicity, which causing muscle weakness, loss of muscle, making the muscle producing or lessing producing force production, and that. I'm going to show you some data who has been done in our lab, effect of doxorubicin on cardiac muscle and skeletal muscle, soleus and medial. Here is found like what's called functional shortening. It's done on rats, by ecography. Also here you've seen DOXA1, DOXA2. DOXA2 is like a dose. DOXA1 is 10 milligram. DOXA2, 12.5. DOXA3 is around 15. Yeah. So what they say, this data say that causing doxorubicin, DOXA2, and DOXA3, decreasing the shortening of left ventricle. That means cardiotoxicity is dose dependent. That means if you have a higher dose, you're going to have a higher cytotoxicity. Also in skeletal muscle, DOXA2, DOXA3, decreasing the maximal twitch force in soleus muscle, type 1, and ADL muscle, type 2 muscle. So, fatigue is one of the most common symptoms of myotoxicity. And actually, when people like cancer patients starting treatment, starting complaining from fatigue. And like this can be people coming like tired of walking to the bathroom, tired of using a route, like using a remote to watching TV. Also people complaining from tired of thinking. And that fatigue can affect on quality of life. So how cancer of doxorubicin causes that? So we found that doxorubicin causes increasing mitochondrial reactive oxygen species. That means increasing oxidative stress in our body, in muscle and skeletal muscle. So how they're doing? Doxorubicin stimulate and aid dehydrogenase enzyme, which generate unstable semiquinone. Semiquinone give like electron or proton to oxygen, forming superoxide. And superoxide is one of the reactive oxygen species. Superoxide causes muscle damage by proteolysis, causing the muscle to protein degradation, and this causing loss catabolic state, and may causes cachexia or atrophy in muscle. Also autophagy, self-destruction, the cells eat itself. Also DNA destruction. So there's data show how doxorubicin increase reactive oxygen. You've seen here in the first one is the heart, the one in diaphragm, and plantaris and soleus muscle increase hydrogen peroxide. So this is one of the reactive oxygen species. Also here, if you've seen the other side, EF, increasing what's called hydrogenyl conjugate is one of the indicator of lipid peroxidation. And this is one of the mechanisms of cause of oxidative stress. Okay, so how our body protect from oxidative stress? There is enzymes called antioxidant enzyme. One of them, superoxide dismutase, is the first defense. What this enzyme doing is catalyze superoxide to hydrogen peroxide and water, and that hydrogen peroxide also is reactive oxygen species, which being catalyzed by another antioxidant enzyme like catalase or GBX, forming water. And superoxide dismutase have a two type, systolic and systole, and the second one is pseudo in mitochondria. So there's like few studies exploring effect of doxorubicin treatment on pseudo-1, pseudo and skeletal muscle. So what's the role of exercise as antioxidative stress? So there's some data show that one single or one session acute of exercise about 24 hours pre-doxorubicin injection can decrease or attenuated cardiac toxicity in rat. This is one session before doxorubicin treatment. So what's about a regular exercise like 10 weeks? Found like 10 weeks of treadmill and wheel running or voluntary running before doxorubicin, also decreasing cardiac toxicity in rat. Also, this is like in our lab study showed that treadmill training attenuated doxa-induced fatigue. Like if you starting exercise pre-treatment can help of decreasing the toxicity in muscle, in skeletal muscle, mainly in soleus muscle. So this another study showed that treadmill exercise protect against doxorubicin. You see here like the graph A. Pseudo has a highly big group in exercise group, also in doxorubicin group, also exercise with doxorubicin, and those in pseudo-1. With pseudo-2, there's no any difference. And also here, exercising with exercise, they have shown significantly higher in exercise and exercise group with doxorubicin comparing to doxorubicin group. So that means treadmill exercise before treatment can decreasing oxidative stress or increasing myotoxicity by doxorubicin by enhancing antioxidant enzyme. This is a treadmill exercise, that means aerobic exercise. So what's about resistant exercise? What's the rule of resistant exercise as antioxidant? So it's been found that resistant exercise have effects leading to several muscular adaptation, enhancing muscle performance, increasing muscle hypertrophy, that means increasing the size, improving the appetite. I think this is one of the cancer population losing for appetite. Also prevent osteoporosis and sarcopenia in healthy people. Sarcopenia, that means losing of muscle. Also one of the common symptoms, signs of cancer population, cachexia or muscle atrophy. So also found that resistant exercise minimizes cancer-related fatigue. That could be which leading to improving the quality of life. So also this data have been done in our lab. It showed that resistant exercise preserve maximal or max twitch force and max rate of force decline in soleus muscle, not in ADL muscle. You see, go here, that side, this is the first one is soleus, that one is ADL muscle. So in doxa, increasing the maximal twitch, also here the force decline. That means improve the relaxation of the muscle. So resistant exercise could be preserved or decreasing myotoxicity by doxa. But how? What's the mechanism? That's why we're looking for mechanism. So also again, few study exploring the effect of resistant exercise, doxorubicin treatment on antioxidant, mainly SUDO1 and 2 in skeletal muscle. So I'm going to show you some preliminary data for our project. So our project, we have around 36 animals have been located or assigned to 4 groups: sedentary group with saline, sedentary with doxorubicin, resistance with saline, and resistant with doxa. Saline here have been used as placebo, and then we exercise resistant for 10 weeks. Then we're injecting with placebo, saline, and doxorubicin 4 times per week, and every dose for doxa is 3 milligram per kg, and total is 12 milligram per kg. And then after last injection, after 5 days, we sacrifice the animal. And then we looked the SUDO1 in soleus muscle. So we found that doxorubicin treatment and exercise training interaction have significant effect by increasing SUDO1 expression in soleus muscle. Soleus muscle is that mean type 1 muscle. For SUDO2, we found no difference among all the groups. So from that, we can suggest that resistance exercise have a role to attenuate or decreasing biotoxicity caused by doxorubicin treatment in type 1 skeletal muscle. So then we start thinking what's happening or how can effect of resistance exercise and doxorubicin in type 2 skeletal muscle. So this my aim for the study was to investigate the effect of resistance barrier and during treatment on SUDO1 and SUDO2 expression in type 2 or FAS, what's called extensor digitorum longus, ADL muscle. So in here, all experiment procedures were approved by Creedon University. How to say that? It's like animal use careful, so it's proved that by. Also, we have the same as I told you before, like if you last 36 male rat have divided 4 group, 2 sedentary group, 2 resistant. One of 2 sedentary we give them saline as placebo, another one doxa, and 2 resistance with placebo, saline, and doxa. So how we exercise them with this exercise? So we put the rat in the cage, and the upper, like above the cage, we put the water and food. So what the rat eating. So what you're doing by elevating the cage every time progressively, that means we train the lower limb, our hand limb. So, and also the study have proved that the elevating cage or this muscle causing hypertrophy lower our hand limbs of rat muscle. Then after 5 days from last excision, skeletal muscle were excised, frozen, and those has been done. So all animal procedures done in Creedon University, and Western blot has been done in our lab at sport and exercise science. And we do Western blot. So Western blot is a biochemical technique. We take the sample. We do homogenize it, and then we standardize the protein. Then we separate the protein by loading in the gel. So we separate. So the gel have a like kind of filter, and like low molecular weight protein going first down, the high giving be stair. Then after that, after separating, we transfer the protein from the gel to membrane, and take this like overnight, like 24 hours around, and then after that we incubate it. Also, we incubated the membrane with antibody for overnight. Then second day we washing, and we keep it with secondary antibody. Then we add doing kind of scan. We're looking for image. We measure what's called optic density, and we'll show some band that. And then we measure the optic density, how much, quantify the protein. And also we use what's another protein is called GAPDH. We use it as loading control. So result. SUDO1 expression in LDL muscle, type 2 muscle, we have find no any difference between SUDO1 expression in all 4 groups. And also this is the band that we see by Western blot. Also SUDO2 expression, we didn't find any difference among those groups, 4 groups. So, what conclusion we say? The dosing has been used. Dosing of doxorubicin have limited effect on antioxidant enzyme in type 2 skeletal muscle. Also, the exercise program itself didn't have any effect. We can say also that maybe resistance may have play a limited role as our modulating DOXA-induced myotoxicity in type 2 skeletal muscle. And so we can compare from type 2, type 1. So also if you go back, the study is consistent with other study with aerobic exercise, the SUDO1 increasing with exercise and DOXA in type 1. SUDO have no effect or have no effect on type 2. Maybe because different type. Type 1 muscle have a lot of mitochondria, have a lot oxidative. So finally, I would like to thank you, my team, and my supervisor, David Heidag, my colleague, Brendan, and Z, Zoltan, and Rikal, and who's a girl graduating soon, and me. Thank you. Perfect.
We still have some time for questions if anyone.
Any question? Brandon, I'm sure you're going to ask.
Have you read any research, in a little bit? I know Soleus is very type 1, EL is very type 2. Is there any research in something kind of in between, get a little bit more type 2 characteristic that has some more oxidative capacity?
To be honest with you, I don't know. No.
I've never seen it.
Yeah, no, I don't know. Yeah, but the only thing, I think from, if you back to, that study, we're using pre-DOXA, aerobic exercise. I think they do 5 days exercise treadmill, then 2 days rest and 5 days, and then inject doxorubicin. They found in soleus muscle, SUDO1 increasing, but did not show any data when in ADL. Also, SUDO2 have no indifference. I think this is more consistent with our study, but we have a different protocol. So our protocol was pre and during treatment. This was aerobic pre-melee. And it was I think total exercise-wise, 10 days, 12 days, 12 including 2-day rest. Yeah. But this is very interesting for catalase. Catalase has been increased with the group scientifically with the DOXA. And I read the article, he didn't give an explanation, or could be kind of defense. Yeah. So the further question is just the dose of the exercise protocol is enough to stimulate type 2 muscle. We do increasing loading exercise. This kind of question, I think. Yeah.
Is doxorubicin taken up? Like, is the same amount of doxorubicin taken up by type 2 muscles as it would be with type 1 muscles? Like, do you get as much?
This is a good question. Actually, we didn't measure that. Yeah, I didn't know how to measure like how much accumulation and yeah.
Has it been measured?
Yeah, for our study, we know. But
Before then?
really, I have no idea. But I think gonna be like increasing type 2, type 1 because they have a lot more blood vessel supply comparing to, and they have like more delivery of doxorubicin to type 1 more than type 2, compared with like histological, yeah.
It does.
Yeah.
Really more in the soles.
Yeah.
But if looking at about at 1 day after an injection, it does accumulate a little bit more in the soleus. Nothing comparable to the heart, though. At least in those tissues.
Yeah. So also like the toxicity is related to dose. As you have a more higher dose, we have a more effect. Yes. Yes, ma'am.
It's a layperson's question. Why did you only test this on male rats?
That's
Would there
good.
have been a difference if you had included females?
Yeah, female like this because different hormone. Yeah, hormonal difference. So if you have if you put male and female, so we're gonna have what's called random factor, because male female rats have a different hormone. So and hormonal like testosterone and estrogen have another effect on our body, not just skeletal muscle. Yes, also have a different effect on metabolism and everything. So with a specific, specially made, so trying to get off what's called random factor who can affect our result. Mainly because hormonal.
So if you could have continued on with your study, would your conclusions, if you went into human study, would you only be able to test this on males?
This is a good question, yeah. If I have a decision, and I'm gonna use specific type of cancer, I'm gonna work on specific type of chemotherapy, and I'm going working on specific type of population like sex. Yeah. But when you apply that on real life, it's so difficult. It's not easy like animal. Yes. And Nick, he can tell you that to recruit people. Yes. Yes. So you know what I mean? Okay. Yeah. We try to get the perfect. It's hard to get it perfect, but at least we get it maybe 75, 60 for perfection. That's. Yes, sir.
Can you explain the difference in what the type of dosing you did with the chemotherapy in this project versus some of the other projects that you cited earlier in terms of a bolus dose, which most of those were, and this type of dosing in terms of its clinical relevance?
Yes. So in our study, the dose we give 4 times for 4 weeks. We give every dose 3 mega per kg. So we total is 12. And I think this very enough shows some kind of effect on my toxicity. But for the study previously I showed that study here with Doxa 2 is about starting 12.5. It's 1 pulse. Yes? Do you answer your question?
I think so. Well, which is more clinically relevant? How do cancer patients?
More relevant with the, because when clinically we're not giving 1 dose. We give I don't know the period, but have a period 3 weeks, 4 months. I don't know exactly, but then give it and separate it. So our protocol is more close to clinical. Here we're looking for acute effect. One dose, how can affect? Yes. And also our protocols, yeah, it could be like we can apply it to clinical, like pre, during, but so difficult to recruit people who have who's suffering from diagnostic with cancer. They have a kind of, I don't know how, tragedy shock. It's hard to convince people to come to exercise pre-chemotherapy. Any question, guys? Perfect. On time. On safe time, yes?
Yeah, yeah.
Thank you.